right now in Congress. There's a group of congressmen that want to eliminate the air marshal system because there haven't been any hijacks since they started the system. So, and that's what we see with vaccines. So vaccines have been so effective, they've essentially eliminated major pandemics and infectious disease. So mothers today say, well, why should I get vaccinated? There's no disease. And not getting vaccinated actually puts all of us at risk because it allows new strains to come in and develop that we weren't vaccinated against. But it's preventative medicine is an intellectual game, and if you don't have intellect, you certainly won't be able to understand it, which is the trouble with the current government. But if you find out for yourself, so what the genome shows is, our close to 8 billion people are all 100% unique. We each get 5 to 10,000 or so spontaneous mutations, so that's why identical twins aren't identical. Plus, they have a lot of stochastic changes when you go from 1 cell to 100 trillion. Yep. But you can run the same experiment over and over and over again, billions of times, and you'll never get the same answer twice. So it doesn't matter what your family history is, finding out what your genome codes for and what your parameters are is the only way to work on having a long, healthy life.
Yep. So they say it's extremely hard to change human behavior or consumer behavior, right? That's, I think, precisely what HLI and companies like Renome is also going for, right? Is to get people to care about their health proactively. How do we do that, right? Obviously, there's the education component of it, which I think you're doing an excellent job of with this room. But we need to do this on sort of a more of a population level. And how do you believe? What are the steps that we as people in industry, in government, and academia need to do to sort of usher in this era of preventive medicine?
So the medical profession, as you guys talked about in your last panel, is the toughest thing to change.
Yes.
It's tougher than the political system or getting somebody to change religion. We offered to sequence genomes of every incoming medical student at UCSD. We had all these meetings about it, and in the end, they came up with a great solution that maybe we should sequence the genomes of a few cadavers and let the medical students play with those. Because about a third of medical school classes don't want to know their own genome.
Right.
So how in the hell are they going to help you interpret your data, which is going to be the principal driver of medicine in the future as we compile all this data and get much better interpretation of the genome. So that's a problem on its own. When we started the health nucleus, we got a lot of grief from a lot of physicians and groups who felt it was unethical to screen healthy people. And my response now, after seeing what we find, my response is, how do you know they're healthy? I can tell you whether you're healthy or not. You can't tell me whether you're healthy. Because the definition of health in the U.S. is the apparent absence of symptoms and you feel and look okay. That's the definition of health. It's a pretty primitive definition.
It's only the definition we've been using for the last 2,000 plus years.
Yeah. So I think we can improve on that, and now with this new technology, it's non-invasive. You can have an MRI every day because we don't use contrast media. 5% of people have an allergic response to contrast media. So that's what pushed this new algorithm. We figured if we had to take 5% of our clients to the emergency room, it was going to be kind of a short-lived experiment.
Sure.
So the new algorithm has improved the MRI readings by orders of magnitude. And having no contrast media, you could have an MRI every day depending on your risk, you can come in at different times. This started at the Venture Institute, which is now in its 25th year, with what we call N of 1 studies. We had a family come to us with a 16-year-old daughter whose younger brother died at age 12 from a glioblastoma. Her genome was sequenced, and she was found to have 3 major oncogenes that were mutated that put her in a very high-risk group for cancer. She had a very rich grandfather who was willing just to pay for any test. So she was put on a monitoring system of extensive tests, but now she just turned 18. She's now studying at UCSD, and basically she just comes into the health nucleus every 6 months for a whole body MRI, plus a few blood tests. And the goal is, because she's at high risk for cancer, to detect it at stage 0 when it first appears, so it's completely treatable.
Right.
As the cost comes down to, $300 or so for a whole body MRI with a complete reading, that's a pretty cheap way to find out whether you have cancer or not.
Absolutely.
Within a year, MRI is going to replace mammography, which is going to be a radical change for medicine. So
Yeah.
it's getting very interesting.
Yeah, for those of you that don't know, mammography right now has about 50% false positive rates. So you're better off flipping a coin than getting a mammography.
And I've never had one, but I have been told it's a very uncomfortable procedure.
Yes, absolutely. So I want to make sure we leave plenty of time to take some questions for the audience. Does anybody have questions? Yes?
Yeah, first just one quick request. I watch a lot of your YouTubes and such, and just more would be great. It's really informative, so would love that. But the question is, how long do you think before we really start radically changing the human, body, mind, all of that through genetics? And is that inevitable, or is that what's going to happen there?
So it's an important question. Sadly, I think it's inevitable. But the steps for getting there hopefully won't happen real soon. We're at the earliest stages of trying to understand the genome, and having people do random edits and changes, trying to cure one disease. CRISPRs have lots of off-target effects. So we're not ready to truly try and edit and change the genome. We need to understand it a whole lot better. Once we do, I think we will not be able to help ourselves from trying to change it to get human enhancement. But don't wait for it.
Okay.
But get an MRI and find out, maybe you'll live long enough and see it happen.
Yes?
How are you dealing with people that already have cancer, like glioblastoma? Are you doing that as well?
So we do have a genomic cancer program where we sequence the patient's genome and we sequence the tumor genome to high coverage, predict neoantigens, predict which drugs are likely to work, which ones are not likely to work. And we're working to use the neoantigens to see if they can be turned into customized, personalized cancer vaccines. But a lot of groups are trying to get a universal vaccine. We think from all the tumor sequencing we're doing that they need to be highly personalized. Compared to what we do in their health nucleus with early discovery, it's a much less rewarding experience to be dealing with people with stage 4 cancer, particularly something like a glioblastoma. But I'd say we've been able to help maybe 35% of people, which is not bad. We've one of the 30-year-old women with stage 4 colon cancer was told by her oncologist that everything was failing. and then she had a few months left to live. We sequenced her tumor, predicted there was a drug that would work. Trying the problem with medicine, it was very difficult to convince her physician to try this drug. I think the woman's husband threatened him and he decided to try it. She's been in remission ever since. So sometimes it really does work, but in cancer, it's very formulaic. Physicians like just put people on protocols and it either works or doesn't work. So finding a really high quality physician that's willing to listen and try and understand this new information is a challenge right now.
More questions?
One over here.
Yes. Great talk. My question for you is, one of the signs that came out of ASCO this year, I think one of the takeaways was that broad scanning for cancer can have, negative consequences, and that we're detecting stuff that would otherwise be inconsequential, not disease that's going to progress and needs to be treated, and therefore sometimes we're then more aggressive with interventions that aren't justified. So I'm just curious how you view this, because I think it's extremely exciting stuff that you've pointed to, but there's a balance here between detecting cancers early and detecting too many cancers that are otherwise indolent or not worthy of treatment.
So if I can be frank, that's largely bullshit that came out of the 1970s when CT scanners first came online. So lots of clinics opened with whole body CT scan. CT is just X-ray, so it can't distinguish between a cyst and a tumor. The new MRI techniques, particularly with our algorithms, can make a very clear distinction, and thus far we've been 100% accurate. But there's real consequences of this in medicine. So we have, there's actually a very large investor. We found and diagnosed that he had a renal carcinoma. He went to a specialist at Stanford who redid their standard MRI at Stanford and said he just had a cyst and he should ignore it. Because we were certain we were correct, we found a specialist at UC San Francisco who understood the technique and was willing to look at the data, who confirmed it was a renal carcinoma. It was proven with biopsy and he was urged to get it out as quickly as possible. So incidental stuff comes from CT scanning where you can't tell the difference sometimes. We do see a wide selection of renal cysts, liver cysts. If they're above a certain size, we tell people to come back for repeated scanning. If cysts are above a certain level, like in the thyroid, standard protocol sort of requires that they should be biopsied. But small cysts that show up places that don't show any hint of cancer, you have to use these modern techniques. You can't use stuff from the 70s and apply it today.
Yes.
With all this new information that you've been learning, what have you seen in the impact of diet and disease? Have you learned new things, or do you make any recommendations?
Yeah. What we have seen is in individuals where we find a tremendous imbalance of their visceral versus peripheral fat. Other parameters such as changes in insulin sensitivity. We've had several individuals that then get incredibly motivated to radically change their lifestyle and change their diet and come back again. Your organ fat is changeable. It's not something you're stuck with. Although I was on a 30-mile bike ride, I was halfway through with the world specialist on liver fat. And he said, exercise won't get rid of your organ fat. And I said, you couldn't have told me 15 miles ago. So dietary restriction is the only thing you can really do. Obviously, burning up more calories with exercise helps with that. There's so many groups that claim, from the microbiome and their genome, they'll get you the exact right diet. I think that's that's also in the bullshit category right now. We don't do that. We will if it becomes a solid science. I think it's more overall calorie intake and knowing what you have. As I said, you can eat all the kale in the world, it's not going to get rid of your brain aneurysm or your cancer. But we give you parameters to shoot for having a much healthier diet and lifestyle.
Yes.
Thanks. Do you have a strong point of view on eating or not eating animal meat as it relates to chronic illness? And are there any supplements you would recommend to the average person?
There is no such thing as an average person, which is really an important thing because any other clinic you go to, your lab values are compared to the average. In my own case, it actually probably sped up my prostate cancer growing. So I was tested for testosterone and had incredibly low levels compared to normal lab values. So I was put on a testosterone supplement. My tumor is very testosterone sensitive, and it probably just caused it to start growing like crazy. Going through my genome, I didn't have any mutated oncogenes, and so trying to work out why I had such an aggressive prostate tumor. And we looked at the androgen receptor. So this is not widely known, but there's CAG or triplet repeats in the androgen receptor. If you have 21 or more of these repeats, you have a very low incidence of prostate cancer. If you have less than 21, your risk goes up. I only had 6. So with all the wild things I've done in my life, I used to be